All right, welcome everyone. We're here on a Monday to talk about something that's kind of interesting, something we've never really dived into before. And we have a lot of diverse guests here that are working on some really cool stuff to chime in. They have a lot of domain expertise. So here we have today with us, we have Kushi from Predicate, we have Kevin from Kalani, we have A Priori from Anoma. So if you all want to do quick introductions, and then we'll dive right into the topic. And maybe we'll start with you, Kushi.
Yeah, absolutely. So my name is Kushi. I lead strategy at Predicate, where we're building policy infrastructure. So we basically set up the rails for application developers and users to set rules on the types of transactions that they want to interact with their application. And so that's what we've been working on for a little while. We integrate with protocols, with DeFi applications, and all sorts of other applications.
Kevin?
Hey, this is Kevin. I'm co-founder of Kalani Network. So you can think Kalani as the solving infrastructure, and then we're not just one solver, but we are this decentralized network that allows solvers to join and collaborate. So in a way, you can think about this sort of like a marketplace where you can access different solvers and as an infrastructure, we allow solvers to also work with one another, right? So in other words, it's not just a place where you come in and express the intent and solver to compete, but they also collaborate to be able to solve intents.
Awesome. I go by A Priori. I work on Anoma. Right now, I'm doing some product discovery work. Anoma is a intent-centric distributed operating system designed to satisfy everything from intent to intent. And we'll have more information coming soon on some interesting product designs.
Okay, great. So our topic today is around designing expressive intents. But before we even get to like what that means, let's maybe dive into a quick definition of what intents are and kind of like how people are using them now, and then potentially some of the thoughts around how they might be used in the future. And anyone that wants to take this, feel free to chime in.
It's like who's going to speak first?
Definitions.
Yeah, definitions. I mean, I will use like a really simple one because I think I've used like the other ones too much. So I'll just say an intent is a way to express what it is that you want without having to worry about how to get what you want. So you can think of an intent like when you talk to your LLM, you have this intent, which is your prompt, and you give it some kind of like constraints or instructions, and then it tries to predict what you might want based off of what you give it. And then it gives you a solution, and then you can kind of like iteratively say whether or not you like the solution or not. So maybe that's not like a specific crypto definition, but I think that's kind of conceptually.
Yeah, and it might be good to talk about some of the use cases. Like what would this be used for in an application?
Sure. So if like today you wanted to express an intent, you could use an application like CowSwap, for instance, where let's say that there are different types of ways that you could express your order. So you might have a preference for a particular limit order. You might have like a TWAP preference. You might have a speed preference. So you might just want a market order. And you kind of just sign a message, and some solvers go and they compete first, and they try to do either a ring trade or coincidence of once. And then based off of their findings there, they will also then look to see if there's any kind of private liquidity via some RFQ or other private liquidity that they have access to. And then they will also look and see what type of routes on-chain liquidity are available. So you as a user don't necessarily need to care about all those things, but those liquidity sources are available to you just based off of the fact that you went to that venue to express what it is that you wanted. And then the other popular place where they're used today is in these cross-chain liquidity networks, or sometimes called intent-based bridges, where a user can say that they want to move funds from Arbitrum to Base, and a solver or a filler will go ahead and fill them on Base, wait for some kind of timeout period, and then be able to go and collect their funds that they had escrowed on the source chain.
And in terms of implementing these sorts of systems, there's probably a handful of different approaches. So I'm curious, like for both Kevin and a priori, like for your teams and your companies, maybe to kind of go over a high level overview of your own designs.
Yeah, so I can get started here. So the for Kalani, we implement the intents based on a primitive we call automatons. Um, and then wait, am I the only person in the show now?
Nader, I think you're muted.
Oh yeah, sorry about that. I think okay, here we go. Hey Kevin, sorry about that. Yeah, yeah. When an individual is talking, sometimes it'll just jump into a solo layout.
Oh,
To
okay.
kind of focus
Yeah,
on
I'm
you.
sorry.
So feel free to
This is being
start
live.
over if you like.
Okay, I'm back. So so for Kalani, we implement this our intent model around the primitive on-chain primitive called automatons, right? Automatons are you can think about them as long-running intent. They allow, because we're a very solver-centric sort of infrastructure. We think about how solvers can let users know, and then how solvers can let other solvers know what they can do. So they can be sort of runtime integrated in together solving intents. So we have this primitive we call automaton. The automaton is essentially like a long-running intent that a solver can express. This is the sort of thing that I can do. And then uh, they can also express what would I like to hear from, right? So we call this a pub sub sort of mechanism, because as a solver, you probably want to hear about the things you can do, right? Or the service you can provide for other solvers. So for us, solvers publish automatons to say, hey, I'm able to, let's say, I'm able to trade USDC and USDT. I can be providing this liquidity on these 5 chains. And because I'm doing USDC USDT on these 5 chains, I can also do cross-chain liquidity on those 5 chains, but around USDC USDT, for example, right? Then I'm going to let other solvers know this is the sort of thing that I can do. So I publish this as a automaton or long-running intent. Say, hey, uh, this is the kind of thing I always want to do, right? So I'm not going to keep, pushing orders into all the, intent venues and whatnot. But you can look into this and then you understand, oh, I could be a counterparty when you express this sort of intent, right? Or you want this to be part of your field structure or your solution. So that would be that would be the primitive that we expose for other solvers. Happy to dive deeper here as well. But yeah, this is the right level if you want.
And I guess for Anoma.
Yeah, sure. That's a great explanation. Thank you, Kevin. So initially, Anoma started out with the vision paper where the problem du jour was coordination. And the idea was to design a system, a large-scale system of coordination without a unidimensional unit of account to allow participants to factor many variables in digital expressions or their values. So the question is like, how do you get there? And so over the years, as the team was doing research and building, what they came to realize is that what they're trying to build is this notion of a distributed operating system. So there are a lot of parts that go into that. And to relate more so to like the blockchain context, there are basically 2 parts. There's a counterparty discovery phase, and then there's a settlement phase. And so you can think of these as both kind of being like off-chain and on-chain. The difference between what you have like with a protocol like Ethereum is that all of these off-chain components are actually brought into the protocol, so you can reason about them. And so in this way, we have a state model called resources, which is kind of a generalization of UTXOs. And with resources, you can load in some custom resource logic, which acts as constraints, which allow you to constrain the type of execution that you might do over those resources. You could also load in a preference via the preference function to describe exactly what it is that you want. So there might be some solutions which are like not quite binary, which might like range from 0 to 1, and you might have some satisfaction preference along that axis. And just like a simple way to think of like the data structure, you could think of it as like an unbalanced transaction.
So in terms of, I would say, user experience, it doesn't really affect like how a application or a user would interact. This is more all, I would say, implementation details around how the system is kind of implemented in general.
Yeah, that's right. I mean, I think for building a world-class UX, the user needs to be mostly ignorant of all of these details. And that has a lot to do with great product design, also user stories, and kind of a vision for maybe where the future of the space is going. I'd be curious actually what Kevin's thoughts are on like ideal front ends and kind of the interplay with LLMs or different things like this.
Yeah, I mean, we've thought a lot about this too. I think the ideal front ends, I mean, there's users and then there are front end developers, and those are not the same, right? So the users ideally just don't have to worry about um, the underlying infrastructure at all. And then the front end developers should act on behalf of the users, where the developers should be choosing, what if if it is more about payments, then what's the underlying payment currency? Maybe the user just swipe a credit card, for example, and then whether it's using USDC or these other dozens of stable coins, that's really the front end developers' job to say, hey, I will do the integration between the fiat rails to crypto rails using this currency. I'm going to use this. Um, uh, if we need to go cross-chain, then pick a specific vendor with hopefully trustworthy and um, uh, or have some sort of economic backing, potentially use eigenlayer, for example. So that's really the front-end developer's job to make sure they protect the users, because otherwise they lose users. And then they will do a lot of the integration. They will do, what Intent Protocol here can do is to make front-end developers' job really, really easy, because the Intent Protocol essentially give them a abstraction to say, give me all the parameters that you want to facilitate this transaction, and then whether it's maybe there's a basket of currency you deem as trustworthy that you can potentially use to facilitate this transaction. It just all depending on at runtime who has the best liquidity and who can give the user the outcome. Maybe there are multiple security vendors that you're willing to trust. Maybe for the specific cross-chain, for example, there's only one vendor that can do this, but they will not always be the same vendor, may not be able to carry out all these transactions, right? So you can say, you can specify, not a fancy word to say this constraint, right? So across all dimensions, you can specify constraints, whether it's about security, whether it's about liquidity, whether it's about latency, right? You can say, hey, I really need this to be done by in 2 seconds because that's what user wants. So the front-end developer can then use intent systems to set out all these parameters, and then you have the actual vendors, right? So if you use the Uber example, this is the front-end developer just say, hey, go to San Francisco, within 2 hours, and then the actual driver to come and say, hey, I can do this, and I will raise my hand and want to be part of this process. So that's the solvers. The solvers are the actual deliver. I guess they produce the actual outcome, right? So they will help to generate this outcome for the users as specified by front-end developers.
So in terms of UX for the user, it's about essentially cost and speed, and I guess expressiveness of like what you can actually accomplish. And then for the developer, are they invoking these through client-side applications or from smart contracts? And I'm sorry if that's a dumb question, but that's the first thing that I'm thinking about.
Yeah, again, this is happy to hear everybody else, opinion here. Like for us, they just sign a message, right? So they just help the user to sign a message, and then the message should include some sort of authority to spend money, because at the end of the day, it's all going to be paid, and then the payment has to come from users, nobody else. And then from there, what other, what's the schematic of this message? Where did it send it to? I mean, this is the specific intent protocols design. And ideal expressive and general purpose general intent protocol should be allow anything that can be expressed to be expressed. Now, the tricky part here is to balance the expressiveness and contractibility, right? So you have to balance it enough so that you can express many things, but then the more you are constricted and expressive, then solver may not be able to recognize this and solve it. So that's the balance between the two, right? So the intent system will help the front end to strike the balance to say, here's how you should express it. It's as general purpose as you want, but hey, solver can also understand what you're saying, so that they can actually do the job.
So I guess to move on, I guess posing a similar question to Kushi in terms of your implementation around policy, infrastructure, and design. I'm curious to get a high level overview there and what went into making the decisions to build it in that fashion.
Yeah, absolutely. That's a great question. So the way that we've built our policy infrastructure at Predicate is we wanted to design it to be censorship resistant. And so we've built a network that's built on EigenLayer, and it consists of a network of operators. And that network has multiple sides to it. So we have our operators, we have applications, and we have information providers all within this network. And the way that all these parties interact together is the application set policies, which policies are just a set of rules on the types of users and transactions that they allow to interact with their application. Then those policies are enforced by the operators in the network. And the way that they do that is they fetch the policy that exists on chain, and they check to make sure that the transaction details that the application gives them adheres to the policy that was set. And if it does, then the transaction is allowed to proceed. And sometimes those policies can use information providers, which is another element of that network. And those information providers can be APIs, they could be on-chain data, it can consist of a wide variety of things. A few of the information providers that we work with often are folks like TRM, Elliptic, Crystal, Cube3. These all provide different forms of information that you can embed into your policies so that you can use things like AML risk scores, identity attestations, you can use geolocation data, like you can use all of these different data sources within your policies. And then there's also some stuff that's built entirely on chain. So our team has built a social graph, which allows you to track basic flow of funds compliance. And then we've also built a geolocation system that allows you to choose what jurisdictions your users can exist in. And so that network exists so that when an application sets a policy for their application, Predicate doesn't have any control over what that policy says or what users are allowed to interact. In fact, it's entirely built and enforced by this network of operators. And so we chose that design intentionally in order to build a system that is maximally censorship resistant while still allowing for expressivity on the application side.
Got it. I'm not sure if you have frozen or not, but
I think my screen is frozen, but I can
there
still
we
hear
go.
everything.
Okay, cool. I wasn't sure if you were finished there.
Yeah,
Okay,
a
cool.
very unfortunate position for my face to be frozen into.
So what you all have built is kind of like a new, I would say, primitive or a new, I would say, like abstraction maybe. So like, can you kind of go into a little bit about what you all just drove you to kind of say, oh, this is a problem that needs to be solved, and we have a solution for that, and we're going to actually go and like build that and make that a company.
Yeah, absolutely. So something that we realized that we predicted almost over a year ago at this point was that in order for traditional financial institutions and regulated capital to come on chain, there would need to be rails for that regulated capital to exist. And it started out with permissioned blockchains where capital was siloed into these environments. But though that capital wasn't allowed to exist with the permissionless decentralized applications that exist on public blockchains. And we're seeing now that issuers of that capital and holders of that capital want to interact with the applications that exist on chain, because blockchains allow primitives to exist that didn't before. And so now these traditional financial institutions want to gain access to the yield that exists on chain, to real world assets, to stable coin systems. And if they exist in these permissioned siloed environments, they can't actually take advantage of the benefits that come with blockchain technology. And so what we ultimately wanted to do was create the rails that allows regulated and open permissionless capital to exist on the same applications. So if you have a Morpho application for lending and borrowing, you can have a pool that consists of regulated capital as someone wants it to be, but then you can also have a pool that consists of fully permissionless capital all on the same application. And when those rails exist, then you ultimately increase the amount of capital that exists in crypto altogether, allowing the ecosystem to flourish.
Super interesting. I think when this starts becoming like used a lot more in practice and people start actually building really interesting applications, it'll probably become more of like a well-known idea. But at the moment, it still seems kind of like somewhat new, correct? Like in terms of like, yeah, got it. Okay, awesome. Now, speaking of apps, I want to dive into apps a lot on both ends, I guess. But maybe I'll start with Kevin and a priori. What types of applications do you see developers building with intents that are kind of uniquely enabled or just maybe enhanced by this technique versus some previous techniques?
Yeah, I think from my point of view, intents will allow. I mean, there are two legs of this, right? There's the Web 2 side of things, and there's Web 3. So if we zoom in a little bit more, like Web 3 native, I think likely to be more immediate. Intents will allow developers to build anything that currently lives off chain that will be sort of living or close to blockchain, right? Close to blockchain adjacent software, essentially, for markets. Those today they exist, but then they're either centralized and have certain trust assumptions. You have to be able to use them, and so on and so forth. Or the market structure of them operating is not ideal, right? So, for example, give you example. With the intents, people can build a off-chain auction network that will take order flow from applications and then optimize the execution or the on-chain settlement for the users or the wallets and whatnot, and also guarantee alignment to make sure this is a piece of order flow middleware that's that can be directed by the app or by the user or by the wallet, right? So this sort of thing today you can build them, but it's very bespoke, right? So you work with a specific vendor, and then you build maybe a TE environment, and then that's it. Okay, so then you have another app that will do the same. They have to build another one, right? Whereas I think with the intent, you should be able to. I mean, this is where the Kalani thesis, right? You should be able to have, if you could have these systems that are carbon neutral and reliable and in a way verifiable as well, then other applications can just build on top of it, right? So this is composability theory. Then you say, hey, you have this already, but I want to tweak some parameters. I want this auctioneer to behave similar way, but then a little bit different. Can I spin out a virtual copy of this and then to optimize for my app, and then whereas the liquidity I want it still to be sort of unified liquidity market. That's more efficient, right? So that's the thing I think with the intents people will build. Yeah, but anything that lives currently off chain, I think, can be directed by intents. So that's where I see things are moving.
Yeah, that was a really good answer. I'd say that's a good dichotomy, I think, between Web3 and Web2. But I would say if you think about crypto applications, it's really just maybe 4 types of primitives: payments, swaps, leverage, yield. And I think as people every cycle try to build new applications, they're around these kind of primitives. And you already saw it this cycle with Hyperliquid success, or even with Pump Fund on top of Radium. It's very successful. We this cycle did start to see some more traction, I think, with social, which was interesting. You had experiments like FriendTech, and then you also had things like Farcaster. So I think there could be like 4, 5, 6, use case 7 that are coming in the future. But at least for now, like the Web3 apps that exist, there's still like a handful of them. And so I think Kevin hit the nail on the head. Like, one of the things you can do is design more expressive auctions, especially when you get into the realm of having things with programmable disclosure where some information is private and some information is public. You can do some cool mechanism design things there. So I think DEXs are one area where we can continue to see a lot of innovation. I think borrowing and lending protocols as well, we can see more innovation there. I think intents for DAOs or intents for blockchains, so to speak, different service commitments and things that services they might be willing to provide each other, whether it's like ordering, storage, or compute. And then, yeah, I mean, I think the golden idea would be any of these Web2 type of setups where you kind of have a marketplace and you can build these different applications on top of this marketplace. So whether it's like riders and drivers, whether it's like job seekers and employers, things like this, buyers and sellers of different kinds.
So beyond finance, it sounded like Kevin was maybe touching on just like general bringing real world Web 2 applications or maybe functionality. How do you feel about some of those use cases beyond some of those just like DeFi and like financial related use cases?
Yeah, I think, I mean, this is the grand thesis, right? So I think whether it's Web 2 or Web 3, the common theme here is whether we want to transact with another person, with the blockchain, with liquidity, and so on and so forth, these transactions are going to be intermediated, right? It's going to be increasingly intermediate. On Web 2, those transactions are intermediated by agents, by AI agents, where you essentially transact through AI agents, right? And you accomplish what you want to do through AI agents. You use vibe coding against some MCP servers and give you some agents, and then you transact through them and automatic integration and so on and so forth. And on Web 3, it's the same thing, right? So this is sort of manifested in MEV protection infrastructure and transaction supply chain increasingly intermediate and then crossing into specific specific situation as well, where relayers and solver intermediate transactions, right? So with that grand sort of picture, you need a counterparty. You need intermediary, just another word to say counterparty, or and then so whenever you want to transact or with the counterparties, you have to give them some task to do, and you have to trust that they can do that for you. So this is essentially the premise of intent, right? You give them what you want to do, and because the reason you want counterparty is because they can do specific things you can't. So you cannot tell them specifically what they should do, because then you can just do it yourself. They possess skills to do things you cannot, which means you give them not the algorithm. You give them the task that's verified by the outcome. And this is what intents really are, right? And then the specific differences in Web 2, it depends on, maybe it depends on reputation, maybe it depends on attestation services. If it is, for example, eigenlayers sort of sit between Web 2 and Web 3, maybe cryptonomics, and whereas Web 3, you can use the blockchain infrastructure itself for on-chain verification as part of that, outcome verification, right? So what I see is this is convergence, whether it's Web 2, Web 3, it's all moving towards this general market. It's a different market structure where it's more peer-to-peer, where it's more discovery-based, where it's you have abundance of counterparties or AI agent that can potentially do things for you, and then you can decide who you want to work with based on some criteria, and then you have to express how you want to check work that is completed, right? So the short answer to you're asking is potentially everything, right? So it's just depending on the expressiveness of the system. It's depending on the verification system that the agents can provide to you. And I mean, really from there, just you can do Web 2 to Web 3, you can do Web 3 to Web 3, you can do Web 2 to Web 2 through Web 3. I mean, this is just, I mean, that's the grand picture here.
Love that. Hell yeah. That was really that was really helpful for me. So this is probably the most important question for a lot of people watching. It is for me because it's hard for me to often like understand the nuance between different implementations of things that try to solve similar problems. So we're going to talk about chain abstraction. What are the main differences between like what intents do versus what chain abstraction is? Can you kind of give someone like hopefully a good explanation of like the differences, the trade-offs, maybe why one is better than the other, or maybe it's not better than the other. Maybe it's more just about trade-offs. So yeah, I'm curious to hear this from both Kevin and A Priori. And whoever wants to take the stab first, I might ask A Priori since
Sure.
he didn't speak last.
I think chain abstraction, it really depends on who you talk to in terms of like what a definition of chain abstraction is. I think the folks at Particle have a very opinionated version of chain abstraction, where it's something like the user never has to worry about bridging again. So they're able to have all of their assets with one balance for each asset, and they're able to, from a single user face, log in without necessarily having to have a self-custodial wallet in the traditional sense, like a MetaMask. They can use their Google account, for instance, and they can then, from that interface, trade across chain as if they're just using one chain. Other people have labeled chain abstraction more as kind of like a movement, understanding that users should be put in the position to have a great experience, and they shouldn't have to worry about what denomination of ETH is on what chain when they're moving assets from Arbitrum to Base. Other people have thought of it more as like an application design pattern, like if you look at Socket. So for instance, the idea being that the application doesn't necessarily need multiple instances deployed on every chain. They can have their own VM, they can have their own execution environment, but they do have some settlement ability on multiple chains. So I think it really depends kind of how you define chain abstraction and what problem you think you're trying to solve there. But I think intents fit really nicely with it in the sense that intents just give you this tool to express what you want. And depending on the architecture of the application or the architecture of the system that you're using and the intermediaries that are solving these intents, you can get different outcomes based off of what you want. So I think the two kind of go hand in hand. But again, like it probably depends on how you would define or what your perspective on chain abstraction is. And I don't think there's an agreed upon clear canonical definition.
Yeah, I will agree. I think, for chain abstraction protocols, if you look at, Particle, Near, and then One Balance, right? These are, big proponents of chain abstraction as a concept, but they have quite different implementations of what chain abstraction is. So I will offer maybe a lot more like detail or technical sort of practical framework to understand intent and chain abstraction. I think chain abstraction protocols, you can think them give you remote controls, right? So I have an analogy of intent and chain abstraction where it's remote controls and crystal balls, right? So chain abstraction give you remote control, right? So users can basically use the chain abstraction protocol to remote control and say, hey, I want to do some transaction on this other chain. I want to just do it, right? So you click a button, and then even you're not on that chain, but then your assets on different chains, but it's remote control. You can click and make something happen on a different chain, right? Where what the intents are, imagine you have crystal balls, What you're saying is to say, okay, I want something to happen in the other chain, but then give me a crystal ball that shows it's already happened. And once it happens, I can pay you on here, right? So one is, so like from systems or architecture point of view, where it's like, I'm going to push away computation that happens somewhere else. One to say, okay, pull something back, pull a proof back to me, something has happened, right? And then to here, then I can express my logic here. So that's my mental model, is remote control and crystal balls. If you find it interesting, I can also give you a link. But that's more like the engineering, like a low-level understanding, the systems explanation of it, right? So you can do the same thing in both ways, and they also have pros and cons as well. One is probably more liquidity efficient. The other one is more IB better and give you better guarantees and so on and so forth. But yeah, they're low-level things. Yeah.
Got it. And I'll ask one more question that maybe we've already touched on here and there a little bit, but it also has a vein of like what we just spoke of. What are the main differences between just a traditional bridge versus what like people say chain abstraction is? Or maybe there is there is no clear definition of what chain abstraction is, like you said before. So maybe there's some overlap there.
Yeah, I can take a step here, right? So first of all, like there's a message passing protocol, right? So those are essentially oracles, right? So they are attestation providers or validators, that some protocols say, and then they can tell you some event that's happened on the chain, right? And then they will attest and then pass it to another chain B and then say something happened. So you can think about that at all. And then you have these bridge protocols, like you said, these are use this sort of cross oracle system to move assets around, right? So if we stay on the crossing oracle side of things, and then we use this chain abstraction versus the intent protocols, then the chain abstraction protocols essentially use this oracle to say, I'm on chain A, right? And then I'm going to generate a message, or I'm going to use the oracle from chain A to chain B. If user is on chain A, you want to use the oracle from chain A to chain B. That's kind of chain abstraction protocol. I mean, they're all a little bit different, but in the end, that's how they use the oracle or the bridge, the underlying interoperability protocol. Now, if you say the user is on chain A, or the money currently is on chain A, I want to use the oracle from chain B to chain A. That's the intent. That will inevitably lead to the intent sort of protocol direction, because you're trying to, like I said, crystal ball, right? You're trying to grab something that's happened somewhere, and then you pull them to local to say, here's the condition that whether the user should release the fund or not, right? So that's the difference. And then the traditional, when you talk about crossing bridges, the lock and burn bridges, the most vanilla form of bridges, it's always from A to B, right? The lock chain asset on chain A, and then you put you release on chain B, or you mint, the asset on chain B. Or you go through a liquidity pool in the middle, and then you swap another token and you raise on chain B. That's always from A to B. So that bridge paradigm is very compatible with this chain abstraction mental model. That's why chain abstraction people say you do not need to bridge anymore, right? Whereas the other direction is from B to A, use the oracle from B to A. That's more of like a market making or market maker, and then you don't bridge assets, you bridge proofs from chain B to chain A, and then you express certain logic based on that. So that would be, maybe that's too low level, but yeah, that's kind of a mental model that could be helpful here.
No, I think that was helpful for me, and I'm sorry to pull you all off topic slightly into that, but that was, I think, helpful. So
yeah, and the practical, like where does this make a difference is when you interact with a Bitcoin, for example, where you can only have one-way bridge, one-way sort of oracle that's actually meaningful, because on Bitcoin you cannot verify something like on a very expressive platform like Ethereum or other chains. But reverse direction is okay. So that is why you can design like really clever systems that, oh, I want to have one-way bridge, but how can I design a still system there? Maybe you can reverse that direction to make it happen.
So in terms of how I would say maybe predicate policies um, have anything to do with how like these intent systems work or how they're connected? Yeah, Kushi, do you want to kind of talk about how predicate kind of fits into all this?
Yeah, absolutely. So the way that I see predicate fitting within the intent system is in two primary ways. So the first is on the side of the solvers. Solvers that are full solvers or partial solvers or fillers, however they exist in a system, they often hold liquidity. And that liquidity, that capital, it may have some rules on who can interact with that capital and how it can be swapped. And so solvers, when they have this capital, they can set policies on who can use that capital, what types of transactions can interact with that capital, what kind of swaps you can see happening with that capital. And so it's basically solver side policies where they can set policies on all of the interactions that are interacting with their solver or that are being filled by their solver. And so that's one of the ways. The second way that I see policies interacting with intent systems is on the user side. So ultimately, policies are a form of expressivity. And for users, they can use policies to set rules and constraints and expressions of how they want their intent to be solved. And so user side policies is basically explaining or slightly explaining or constraining the way that the intent solution happens. And so both on the solver side and on the user side, you can set these policies. And then when they interact with each other from both sides, it becomes a very complex system, but also a very expressive system for all parts of that solving process.
So, what would be some of the use cases or examples of when this would be a good idea to kind of take advantage of?
Yeah, absolutely. So it comes back to bringing regulated capital into like permissionless environments. When you bring this capital in, there may be policies on who can interact with it, right? Like if the capital deployer is based in the United States, then they might have laws on who they can actually service liquidity for. And so you can see those policies being set on this type of capital where you're limiting the users that can interact with it to certain jurisdictions, or you're setting basic AML checks, or maybe even identity verification. Similarly, from a user perspective, maybe there are specific solvers or specific systems that I trust to fill my intent. And so if I know that those entities run solvers, then maybe I would only want those solvers to fill my intent. So if you're seeing like how banks interact with each other today, they often do this through bank-to-bank transfers, or they'll have correspondent banks in the middle that they trust to facilitate transactions between financial institutions. And so if we ever want these intent systems to service very expressive orders for bank-to-bank settlements or for cross-border settlements through different financial institutions or maybe even government bodies, then they might have specific trusted entities that they want to fill those intents for them because they know that the capital on that other side is capital that they're comfortable with. And so you can see that policies end up becoming a very expressive way to decide how different parties interact with each other and how these orders are ultimately filled on chain.
Got it. Makes sense. So, similarly to how I would say predicate is just used in general, it just applies to this as well, because some of those make sense for a lot of other use cases in general. Is that right?
Exactly, exactly. Policies basically seamlessly fit into intent systems is just a basket of constraints, basically.
Got it. Okay, cool. Well, I think we're getting close to being finished on time. So before we do that, is there any big topics, big points that anyone wanted to make before we get into the last question? Okay, good. Everyone seems to be good. If you do have something, feel free to chime in. But so to wrap this up, we're gonna do like a quick rapid fire. What are your spiciest takes about the intense space? And so I'm gonna just call on someone. I'm gonna start with Kevin.
I think everybody's moving toward intense, but it's it just people probably don't know, or people either intentionally or unintentionally. it's I see a lot of new protocols really working into this direction, but the form factor is different. I hope that's spicy enough.
That'll work. A priori,
I'll say something spicy, half baked. I think intents are the inverse of MEV. I think they solve a lot of our MEV problems. Not all of it, because there's some new specific types that will emerge. But yeah, I think they solve a lot of it.
super interesting take. Kushi, do you want to chime in or?
Yeah, for sure. I think that developers are severely underutilizing the power of what intents can be. They're simplifying it a lot to simple RFQ systems, but there's so much that can be done with intents, and I feel like today's applications don't do it justice.
I don't really have a spicy take, but I can just tell my perspective from someone from the outside looking in that's a developer that works with a lot of teams that are building similar like products in the sense of like we're building different infrastructure and application layers, but isn't specialized in this. I would say that number one, people don't really, unless you're like deep into this, like know the exact trade-offs and differences between some of these different approaches. Like we mentioned, maybe what chain abstraction is versus what intents are. That would be one general take. Number two, I feel like there isn't like a clear winner in terms of like, oh, I want to go build something and I'm going to use intents. Like, which product am I going to use? And then I feel like there's a big opportunity for someone to build like the best in class API or the best in class just product to kind of win that whole space because it's still kind of up in the air. And maybe like more education around just how to actually build using these different primitives and like high quality educational material and maybe reference architectures and things like that to kind of get people excited about the potential here. But that's kind of it. So I learned a lot. I really appreciate everyone's time. I know everyone's super busy and you took an hour out of your day to come be here to either be on this with me or to watch it. So thanks for your time. We're going to be sharing links and the YouTube for all the different projects that we kind of talked about here in the documentation for you to check it out. So that's it. Thanks for everyone chiming in today. We'll be back with another Infinite Layers actually later this week.
Thanks, everyone.
Thank you.